the total surface area of this figure is found from 2LW plus 2LH plus 2WH. Another kind of prism is the triangular prism, also known as a wedge. Yes, that's right. Think of the wedge we use under a door. As the name suggests, it has a cross-section which is in the shape of a triangle. Let's say this wedge has a length of 20 centimeters. Its cross-section has a base of 8 centimeters and a height 6 centimeters, with the third side measuring 10 centimeters. How would we find its total surface area? The wedge has 5 faces, 2 triangular and 3 rectangular. Looking at the cross-section, we see that it is triangular. So we find the area of the triangle, which would be half times 6 centimeters times 8 centimeters equals 24 centimeters squared. Next, we find the area of each of the rectangular faces. 10 centimeters by 20 centimeters, 20 centimeters by 8 centimeters, and 20 centimeters by 6 centimeters. Therefore, the total surface area of the wedge would be equal to the sum of the 3 rectangular faces and the 2 triangular faces. This gives us 528 centimeters squared. The pyramid is another type of solid object whose surface area we can easily determine with the use of formulas. We will look at the pyramids that have a triangular base or a square base. A triangular based pyramid is called a tetrahedron. And to determine its total surface area, we find the area of each triangular face and sum these areas. The same principle applies to a square-based pyramid. We find the area of the square base and add this to the areas of the 4 triangular faces. Another kind of solid object is the sphere. What everyday object can we think of that is spherical? How about an orange? If we have an unpeeled orange with a diameter of 7 centimeters, how would we find the total surface area of the skin of the orange? Due to its circular nature, the orange has a total surface area formula which is equal to 4 pi r squared. So after we find the radius of the orange, which happens to be 3.5 centimeters, we can find the total surface area of the skin, which is 153.86 centimeters squared. Now all of the objects for which we have calculated total surface area have been based on standard geometric shapes, for which ready-made formulas exist. But just as we combine formulas for different geometrical shapes when calculating the surface areas for a wedge and square-based pyramid, so you may encounter objects that require not only the use of more than one formula, but even some ingenuity in adjusting these formulas to determine the actual surface area. Until our next lesson, I am Renee Brown. So far, we have been looking at simple equations with one unknown. But what if we have 2 unknowns in 2 equations? These equations can be solved at the same time. Hence, they are called simultaneous equations. Simultaneous equations can be solved algebraically by the elimination method or the substitution method. In the elimination method, as the name suggests, we eliminate an unknown which has numerically equal coefficients in both equations. For example, Richard is X years old and his father Raymond is Y years old. The sum of their ages is 69 years. The difference between their ages is 27. Determine Richard and Raymond's ages. The equation for the sum of their ages is y plus x equals 69. And for the second equation, y minus x equals 27. Since in both equations the two variables have the same coefficient numerically, we choose either one to eliminate. In this case, we will eliminate x. Since they are the same numerically but have opposite signs, we add both equations. When we do, we get 2y equals 96. Of course, this makes y equal to 48. Now that we have a value for y, we can now substitute 48 for y in any equation. So if we choose equation 1, then x plus 48 equals 69. So x would be equal to 21. Therefore, Richard is 21 years old and Raymond is 48 years old. When the coefficients of an unknown are numerically equal in both equations and also have the same signs, the equations are subtracted. Let us look at the two equations, 4x minus y equals 13 and 3x minus y equals 9. Since in both equations the coefficient of y is negative 1, we subtract the equations to eliminate the y. When we do this, we now have a value for x, which is 4. We can now substitute 4 for x in an equation. Let's use equation 1. Since we are substituting 4 for x, we end up with 16 minus y equals 13. And hence, y is equal to 3. So our solutions are x equals 4 and y equals 3. Sometimes we are given a pair of equations in which none of the coefficients are numerically equal. In this case, we multiply one or both equations by constants to form new equations with equally numerical coefficients for one of the unknowns. Let us look at the equations 4x minus 3y equals 11 and 3x minus 2y equals 8. Since none of the coefficients are numerically equal, we choose a variable to eliminate. Let us eliminate the x. So we multiply equation 1 by 3 and equation 2 by 4. Our new equations are 12x minus 9y equals 33 and 12x minus 8y equals 32. Since we now have coefficients that are equal and have the same sign, we subtract. We now have negative y being equal to 1. But we still have to solve for y. In order to completely solve for y, we divide negative y and 1 by negative 1, since the coefficient of y in this case is negative 1. So now y equals negative 1. Now that we have a value for y, we substitute -1 for y in an equation. Let's use equation 2 this time. When we substitute -1, we get 3x plus 2 equals 8. And therefore, x equals 2. So the solutions are x equals 2 and y equals -1. To use the substitution method to solve a pair of simultaneous linear equations, rearrange one of the equations to make one of the variables the subject. To identify which equation to rearrange, select the one which has one variable with a coefficient of 1 or -1. For instance, in the equations 2x minus y equals 8 and 3x minus y equals 13, in this case, we can rearrange any of the two equations to make y the subject. But let's choose equation 1. Therefore, y equals 2x minus 8. Since y is now equal to 2x minus 8, it means that anywhere we see y in equation 2, we replace it with 2x minus 8. This gives 3x minus 2x minus 8 equals 13. This is simplified to x plus 8 equals 13. Our solution is therefore 5. We next substitute 5 for x in equation 3. So y equals 2 times 5 minus 8, which is 2. Our solutions are therefore x equals 5 and y equals 2. Simultaneous equations can also be solved graphically. We draw two lines using the same axes. The coordinates of the points of intersection of the two lines are the solutions to the equations. This will be done in another lesson, but we first need to learn how to draw simple linear graphs. In algebra, we have what are called algebraic expressions. An algebraic expression consists of one or more algebraic terms in a phrase that may include variables, constants, and operating symbols such as plus or minus signs. An algebraic expression is only a phrase, not a complete sentence. Therefore, it does not include an equal sign. To simplify an expression, we must remember that only like terms can be grouped together in order to be added or subtracted. What do we mean by like terms? We mean terms that have exactly the same variable. For example, 2jk and negative 3jk are like terms because they both have j and k in common. On the other hand, 3am and 10amp are not like terms. Although they both have a and m in common, the second term also has a p. How about 15ahg and 2hga? Are they like terms? Yes, they are, as the variables are exactly the same. Note that the order of the variables does not matter. In order to simplify 3a plus 7a minus 15a, we note that all the terms have the same variable, a, and therefore can be grouped. In order to find the answer, we have to add or subtract the coefficients. The coefficients are the numbers which appear before each variable. So 3 plus 7 minus 15 equals negative 5. And therefore, 3a plus 7a minus 15a is simplified to negative 5a. What about 4am plus 10ad minus 7am plus 2ad? In this example, we have two sets of variables, am and ad. So how do we go about grouping like terms? Let us rewrite the expression putting like terms together. 4am plus 10ad minus 7am plus 2ad becomes 4am minus 7am plus 10ad plus 2ad. Notice that when we move the 7am, we also move the minus sign. The sign is like the head of the term. When we walk towards the door, we don't leave our head on the couch. In the same vein, when we move a term within an expression, the sign in front of it moves with it. Now that we have grouped the like terms, we can simplify the expression to negative 3am plus 12ad. Note that the expression cannot be further simplified because we now have two unlike terms. Let's look at another expression. 4 times a minus 3d plus 8a. In this example, we have brackets. So let us look quickly at what to do with our brackets. In order to remove brackets, we apply the distributive law. This law instructs us to multiply each term inside the brackets by the term that is outside. So a times b plus c is equal to ab plus ac. Now back to our example. 4 times a minus 3d plus 8a. In this example, we are going to multiply the two terms in the bracket, a and negative 3d, by the term outside, the 4. This gives us 4a minus 12d plus 8a. The 8a has not changed as it is not inside the brackets. Now that we have removed the brackets, we can continue as in the previous examples. So we group our like terms. Therefore, 4a minus 12d plus 8a becomes 4a plus 8a minus 12d, which can be simplified to 12a minus 12d. To simplify 2 times 2am plus 3xy minus 5 times am minus 2cd, what would we do? In this example, we have two sets of brackets. Again, we apply the distributive law. So we get 4am plus 6xy minus 5am plus 10cd. Note that in expanding the second bracket, we multiply the terms inside by negative 5. Remember, the sign is like the head. Did you know that there are fractions in algebra? Indeed, there are, and they are treated just like regular fractions. So for example, if we are to simplify a over 5 plus a over 10, we first find the LCM, which is 10. We then divide the LCM by the denominator of each fraction and multiply what we get by the numerator. So 2a plus a over 10. Since the numerator has like terms, they can be simplified to 3a over 10. What would happen in the case of an expression like 3 over 7b minus 2 over 3b? As in the previous example, we start by finding the LCM of 7b and 3b. That would be 21b, since that is the lowest term that both 7b and 3b can divide into. The expression would therefore simplify to become 9 minus 14 over 21b, which can be further simplified to negative 5 over 21b. Let's simplify another expression. 3x over 5y plus 6y over 8x. The LCM of 5y and 8x is 40xy. Applying the same principle, it would simplify to 24x squared plus 30y squared over 40xy. How would you simplify an expression like 2x plus 3 over 4 minus x minus 2 over 3? Again, we find the LCM, which in this case is 12. Then we divide the LCM by each of the denominators and multiply the numerators. 3 times 2x plus 3 minus 4 times x minus 2, all over 12. This is equal to 6x plus 9 minus 4x plus 8 over 12. To complete our simplification, we have to, as usual, group our like terms. 6x minus 4x plus 9 plus 8 all over 12 would be equal to 2x plus 17 over 12. So now that we know how to simplify algebraic expressions, we will move on to solving linear equations next. Until then, I am Renee Brown. One of the things used to differentiate us as individuals is the name we are given. In the same way, a straight line also has a name that distinguishes it from other lines. These are called equations of lines. Y equals 2x plus 7, y equals 3x minus 10, and 3y equals 6x minus 12 are all examples of equations of straight lines. Each of these equations provide a link between x and y coordinates that lie on these lines. Let us look at the equation y equals 2x plus 7, for example. To show this line on a graph, we would need to find the coordinates which each point on this line depicts. We select a range of values for x and substitute them into the equation to find the corresponding values for y. So let's say the values of x we choose, called the domain, are -2, -1, 0, 1, 2, and 3. We first take the -2 and substitute wherever we see x in the equation. So we get y equals 2 times -2 plus 7, which is 3. So our first set of coordinates which will lie on this line is -2, 3. We do the same for -1, 0, 1, 2, and 3. So our coordinates are negative 2, 3, negative 1, 5, 0, 7, 1, 9, 2, 11, and 3, 13. We then plot these points on a graph and draw a straight line through them. Please note that once the equation is linear, the coordinates will always lie in a straight line. Or to say this another way, once the coordinates lie in a straight line, we have a linear equation. Let us look at another equation. 3y equals 9x minus 12. What do you notice about this equation? Yes, there is a number or coefficient in front of y. What if we were to divide the equation through by the coefficient of y? We would end up with y equals 3x minus 4. Now it looks like what we are used to. So again, we select values of x and substitute to give us the coordinates to draw the straight line. So we see that 3y equals 9x minus 12 is the same as y equals 3x minus 4. Could you think of another equation equal to this? How about negative 4y equals negative 12x plus 16? Equations of lines have a gradient. The gradient of a line, also called its slope, refers to the steepness of the line. Look at the following two pictures. Who has the easier climb? The one whose slope is less steep would have the easier climb. There are two components which affect slopes, the vertical rise and the horizontal run. The gradient or slope of any line is the ratio of the rise to the run of a line. If we look back at the equation y equals 2x plus 7,